The entire system needs to be balanced in the sense that you need to have a sufficient amount of kilowatts provided to achieve the extraction rate, the recovery rates that you want, but you also need to have the circulation speed to be able to keep up with how much heat is being pulled out of your heatings.
So it's a gallons per minute constraint there. Like the pump on that little lab heater just can't keep up with the amount of kilowatts of heat that needs to be delivered to the collection vessel.
That's exactly it, yeah. So you'll have your heating fluid will be returning extremely cold because it's just circulating too slowly, even if you have sufficient kilowattage in that heating system.
And then one of the things that I actually see people do to counteract that is they start cranking up the temperature.
Yeah.
But ultimately that really does nothing because it's just a short-term fix. It's really the amount of energy and not the temperature that is the constraint.
Yeah, and you know, you can squeeze a little bit more by having a little bit of a higher delta T on the inlet of your jacket, but ultimately the solution to the problem is increasing the flow rate of that heat circulation.
The other thing that's kind of an issue with these things is they have reliability issues sometimes. And if you don't maintain them, then they can break down. A breakdown in a key component like a compressor, if you're relying on that for your extraction process, and then all of a sudden it's out of service, your entire facility essentially grinds to a halt. And you know, that can be very, very expensive. So a lot of times what people will actually do is they'll have a backup. And that's also, you know, if you're gonna have a $20,000 recovery pump, then you also need a backup. You're looking at pretty comparable costs from CapEx perspective to just replacing it with a better solution.
Yeah, the compression of gas is a pretty intense process in the sense that you have this piston that's applying a lot of force to the gas. You have these seals, you have sliding components, you have one-way directional valves, you have all, and the PRVs, you have all of these things that can go wrong. And so, you know, simplifying that to a heat exchanger that just has a gas condensing on it removes a lot of risk from that.
So there's no moving parts.
Yeah, exactly.
Right? It's other than, or you're externalizing those into something that's a little bit easier to maintain, like a chiller. The other thing about these compressors is that it's a specialized piece of equipment. There's not a lot of technicians or, you know, in various parts of North America that understand how to work on these, have the parts available. You know, if you're replacing that with a chiller that's just condensing, like in a passive recovery scenario, chiller technicians are everywhere in North America, everywhere in the world. Yeah, people can service chillers.
That's right, and chillers are kind of, you know, it's a different style of compressor inside of a chiller typically, especially on the industrial units, and they're very robust, and you know, there's a lot more of them out there, kind of thing. And those compressors are ultimately a lot more reliable in the chillers.
The other thing is that they're outside of your room, so they're not taking up any real estate in the most valuable part. And we recommend the outdoor chillers as well, so you're not actually rejecting heat into the facility. A lot of our customers, we actually see them putting chillers indoors, taking up valuable real estate, even if it's not in the C1B1 booth, it's still rejecting the heat from your process into your building. Now your building's HVAC system's got to deal with that.
Yeah, exactly. You have to have the makeup air, you know, adjusted to be able to account for that. And a chiller outside really is a fantastic solution because it's very easy to pipe those chiller lines through the wall.